Hey everyone, this is Merrick with General Lattice, and here I want to run through a helmet demo application for Frontier, and wanted to highlight some of the workflow steps of how I got here. So let's jump right into it here, and I'm going to open up our favorite CAD modeler, in this instance being Rhino 7. And here you can see assembly data, B-rep geometry, that I've actually imported from GrabCAD. Let's just go take a look at that really fast. Thanks to Mohammed here, I went and downloaded the step file to my computer and imported it into Rhino. And I just took the geometry and broke it out into individual layers and block instances. Uh, Rhino users will know of block instances, and just basically created some clean, broken out model that I can easily reference. You can see here different block instances. So I'm going to turn on everything that I would like to use to Lattice and to add some features, and I'm going to export it as a step. Grab all of this, export selected, export as a step file. Can also do that in different CAD software. Here we have Autodesk Fusion 360, and we can see nested bodies and components here. Just turn off some of these. You can see we have the same design in Fusion. Just like Rhino, you can also export this as a step, going export, selecting step file here, and saving it to your appropriate place on your computer. So now that we have our step file exported from our machine, let's go over to Frontier. Turn off our lattice I have made. And so let's get started within Frontier within our Design tab. So within the Design tab, to get started, what you would want to do is hit Upload. So we'll go and find that step file that we exported from our favorite CAD software, and we'll hit Open and load our geometry into the scene. I already have that done here, so I'm just going to turn all of our parts on to save some time. So now in the scene, we can see, and in our body tree, we have multiple bodies and elements all broken out. Now, this is where Frontier becomes really exciting, is the integration aspect. So the idea of taking a lattice with known mechanical properties and putting it into your desired 3D volume. So let's isolate the 3D volume that we want to lattice. In this case, I named it Lattice Design Space to make it easy to find. And so this is what we can see here, is this nice looking B-rep shape. And so to integrate a lattice into this shape, we first want to go to our library. And I just want to highlight this quickly. This library is a set of lattice geometries that we call digital materials that have their parameters stored alongside their mechanical properties. So if you look across all of these different samples, you can see different shapes, different thicknesses, different sizes, and we've gone and mapped mechanical properties to these lattices. So when I go and I like a material, a specific material that will fit my application, I can add it to the folder that I want, and I can actually integrate that into my material. So I'll go ahead and hit accept. It already says that material's in there, and I'll hit OK. And now let's go back to our design tab. I'm going to go to my projects. This is nice. It gives a sort of Windows Explorer version of all your Lattice projects. And so now here we can see the materials I've added to our design project. And you'll note there's raw material as well as the hardware that they're manufactured on. So let's go back to our design tab, now knowing we have the material IDs we want to integrate, and we'll now isolate our design space again, being this purple body. So now this is where the fun starts. We'll hit integrate, and we can see we have our body trees replicated in this window, just like over here. And we'll go and find the body that we want to put a lattice in. So in this case, we named it lattice design space. So we'll select that, and we'll select the materials we want to integrate. This is parallel, so they'll run at the same time, which is nice. So we have this integration complete, and we can now go and turn on these bodies, having one material ID here, and the second material ID here. And so again, I just really want to reiterate what's really exciting is this is not generating a random lattice based off your design space. This is generating a lattice based off of parameters and mechanical properties we have stored. So we now know the bulk properties of this digital material. So very exciting. Not only can you get actual lattice geometry within your space, but you can actually now have bulk properties as well, skipping lots and lots of R&D and iteration time, skip slamming your head. And another thing about the structures all generated is they've all been validated for manufacturability. So Frontier will not suggest or generate a lattice that cannot be manufactured. So now that we have our lattice here, I like this triangular based one. So let's add some features to this. We can see when we overlay our initial design space, we have potential areas where members may stick out that we may not want, and we may just want the lattice to be flat or smooth through our design space. So what we'll do is we're going to actually union together all of these skin features that we created in our CAD. So to do that, we're going to go to Boolean, go to union, and start selecting what we want to join together. So we're going to say we want skins, we'd like the brim, we don't want to add the outer, we'd like to add this other set of skins, the third set of skins, and then finally we don't want the inner as well. So we'll hit apply, and we can see this Boolean starts to run in the background. And as we wait here, we can start to prepare our scene to look how we want. Just hiding geometry we don't want to see at the moment. And we'll wait for this Boolean to return. Now, if we go over to the parts page while we're waiting for the Boolean, oh, maybe faster than I thought, we can see that we now have all of our pad geometry as a single part. Now that we have that, we can actually grab this Boolean again, and let's do another union. And let's add this actually to this lattice we've created. So now we can see we're going to join this lattice to our Boolean, and we're going to hit apply. And repeat that same sort of process where we're going to hide the parts that we don't want. We can also have the ability to rename parts or Booleans, which can be really useful. So we'll say joined skins. And now while we're waiting for this Boolean, we can hop over to the parts page. So what's exciting about the parts page is it keeps and stores all of the geometry that you've created within Frontier and allows you to either download the STL or geometry file or select a supplier that you can order from. So now that we have a Boolean returned here, we can see that we've joined the lattice to all of these skin features that we would like added to it. And so the reason we do this is you can see there's some members extending past our initial design space that may not be ideal. And you can see these sort of tabs added on top. This was done on purpose in our CAD geometry. If we turn on some of these skins here, we can see that the skins were modeled to extend inside of and outside of our initial purple space to ensure that we encapsulate all of this geometry. So now that we have all of our geometry or all of our features joined to our lattice here, we can now go and cut this smooth with an intersection and get back a really, really smooth result. So let's do that. So we're going to go to intersection and we're going to select this Boolean we've created and we're going to select this initial design space to intersect with. We'll hit apply. Going to rename this with features. I'm going to hide that as well. And now we can wait for our Boolean to be returned with our final lattice. To go back to highlight that parts page again, we can see more and more parts being added to here as we create more and more parts. So again, having the ability to get this part printed and get the part in hand is the goal, but also the ability to download the file to bring it back into other software. So here we can see that we have our result from the Boolean and a really, really exciting clean cut to our initial design space, which is really, really useful. So if we go back and turn on this initial shape, we can see how much we've removed from that initial lattice and see that it resulted in a clean, flat, flush cut to our initial design space. Actually, let's overlay that to see how good of a cut we got. Yep, really good cut. Awesome, so that's exactly what we were expecting from the tool, and we'll go ahead and name this Final Lattice, and we'll navigate to the parts page, and we can see here generating STL is working on it in the background, working on generating our geometry. And when that's done, we'll be able to select it and download that file. Or again, ability to find a supplier where you can get this part in hands. So I'll select this lattice and I'll hit download. This file will be zipped and added to your downloads here. I've already done this, so we'll save some time. Let's go back to Rhino and take a look. So we have our initial space. Let's go ahead and hide our inner and outer and all of our features. Oops. Great, so we just have the initial design space we were looking at. And now I want to turn the inner and outer shell on. And to get the lattice back in, you can either import a mesh, drag and drop the file, or here I already have it prepared. And now I can hide our outer shell and see our geometry. So just highlighting the full process of taking a step file from your favorite CAD geometry or CAD modeler, uploading it as a step file to Frontier, and being able to see that back in your CAD software is how we imagine an ideal workflow to be used within Frontier. Can also show this in Fusion as well, bringing our geometry back to our design space. Again, can be really powerful for assemblies and understanding how the lattice ultimately mates and interacts with your rest of your parts. So let's turn that lattice on, and we can see here we also have the lattice back into Fusion. So downstream processing, all the things you may want to achieve in your normal CAD process can now be done with any CAD modeler and Frontier. I think that pretty much covers it. Thanks for listening in. Stay tuned for more videos. Thank you.